I haven't really had a chance to look at this stuff. I appreciate you sending it in advance, but today was kind of a wild and crazy day. So, but you should be okay here, except that thing. Well, I'm hearing a strange dial tone. You hear that?
No.
Okay. Yeah, it's like the old modems where you would hear the dial tone. Let's take a look at 19. Function shown is not differentiable at 4 different values on that open interval. Name those values.
Well, x equals 0 would be one of them.
Okay.
For sure.
Uh-huh.
And then x equals 3.
Okay.
And x equals 3.5. But I don't know the fourth value.
Well, that's an excellent question. Huh. There is one thing that, well, this is a great problem, okay? Because the question is it differentiable at -1 or 4? And if it is not, because they're open circles, then there would be 5 points, correct?
Right.
So one of them, it's differentiable, and one of them, oh no, there's another point here that we didn't notice right there. 1.
So 1 would be also.
Yeah. Huh. Kind of destroyed what I was about to say.
Well, I have a question though. So with 1, the limit exists, so.
True.
And the function, but the function is not continuous. That
Exactly. Definition of continuous is the left side limit has to equal the right side limit, and both of them have to equal the value of the function at that number.
Right.
In this case, that doesn't exist. F of 1 does not exist. So it's not continuous there.
Okay.
I did have some other thoughts. Yeah, they weren't valid now that I think about it. I was thinking that this has to end with a cusp, doesn't it? And then, no, it doesn't really. In other words, it could end like this. So
right.
It's not necessarily going to be a cusp. So I guess it does answer the question, is it differentiable? Well, in the open interval, those points really aren't in that interval.
Right.
So I don't really know. I don't think it is differentiable at -1, and I don't think it's differentiable at 4. Kind of surprised they didn't say there were 6 points, because it appears that there are 6. I don't know how it could be differentiable right there, any more than it's not differentiable there. The limit from the left is not the same as the limit from the right. I've always been a little puzzled about that, about endpoints and differentiability, especially if they're open like that. All right, here we go. First of all, if h of x is equal to f of g of x, what's h prime of x equal to? That's the key to this question.
Okay.
It's the only way to answer it, I'll bet. I haven't looked at it in detail, but just...
Well, h prime of x would equal...
Use the chain rule. It's the derivative of the outside times the derivative of the inside.
So it would be f prime of g of x times g prime of x.
Perfect. Now we should be able to answer this question over here. So we need to know, first of all, what g prime of 14 is. Does they give us that? Yes.
Yeah, it's 5.
Okay, so it's f prime of We'll do it step by step. Now, what is g of 14?
2.
And now what is f prime of 2?
12. So 12 times 5 would equal 60.
Yep. And that's all you ever have to do on those. And if you don't get that first step, you're not going to get the problem, I don't think. I don't think there's another way to do it. You just have to apply the chain rule to that composite function. And that's actually a pretty important part of calculus. It's this that makes U substitution recognizable. You know how I'm always saying that if the derivative of the U is in the numerator right there, then it's U substitution. And you want to recognize that pattern.
Mm-hmm.
All right. 21. Let me scale down here a little bit. The graph, the right represents the graph of the derivative of which of the following functions? Well, this can't be too hard. That looks like a straight line, right?
Yeah.
In fact, we can figure out what the equation of that line is. Let's do that. What's the equation of that line? Instead of y equal mx plus b, what is it?
Well, the answer would be b.
Okay, you took the shortcut. Well, how do you know it's b and not d? Because the y-intercept is not 0, yeah.
Well, yeah, the y-intercept isn't 0, and the slope was 6.
Yeah. I guess there's a couple of ways to do this problem. You can just take the derivative of those 4 functions and see if any of them match the equation of that line. Or you can figure out the equation of that line first, which I was doing, and then figure out the derivative of each of those 4 and make sure that they match. That's all. Relatively straightforward and easy problem. 22.
I have trouble with these.
Well, everybody does, and it's always puzzled me why they start out differential calculus with this. They don't start out giving you the easy power rule or the easy quotient rule or the easy product rule or the easy chain rule. They start out with this ridiculously hard quotient definition for first derivative. But what the first derivative means is this. The limit of f of x, f of x plus h. And one way to remember that is that everything prior to calculus was x minus h, remember? Didn't matter whether you were talking vertex format, conic sections, no matter what. It was always x minus h. And I tell all my pre-calc students, you will not run into x plus h until you get to calc. And then you run into it in droves. So we know it's x plus h minus f of x. That's the numerator. The denominator is h. And we're doing it as h goes to 0. Okay? So that is your basic definition of first derivative. That's the ultimate. That's where you start. If you were just discovering calculus, or if you were just inventing calculus, or discovering it, I guess, that's where you would begin. Okay? The product rule and all those power rules, those came from this.
Right.
Okay, so if we apply this to this function, the best way to do these is to go ahead and list what f of x plus h is.
Okay.
This is f of x. So what is f of x plus h?
Would that be 2 times x plus h squared?
Yep.
plus 4.
Yep. What is f of x?
2x squared plus 4.
So now what we're looking for is f of x plus h minus f of x. Do we see that down there anywhere?
It'd be C.
Well, first of all, it looks like A. What am I missing here?
The limit, I think.
Ah, thank you. I totally missed that. You're right. So that's not, in other words, we can cross this out from consideration and this.
Okay.
And yeah, that is, you're right, C. In other words, that numerator is f of x plus h minus f of x all over h. And they use delta x instead of h, same thing. Whenever you're letting something go to 0, that's what a differential is, technically. When you talk about delta x or delta y or whatever, you're talking about an extremely small number that's approaching 0.
Right.
Most books will use h. I actually prefer delta x myself because it gives you more of an idea of what delta means. It's the differential.
Okay.
All right. Is that the last problem on this page? I think so.
Yeah, it is.
Okay. Yeah, this is the next one, okay. Okay. So, what are we going to do with A? 3 times what? F of what? Let's write it like that. Let's just write it before we even look at the table.
Okay.
Right? Correct?
Yeah.
Okay, now let's figure out what f of minus 1 is.
0.
Uh-huh. And let's figure out what g of minus 1 is.
Well, do we have to take the derivative or?
No. No, none of these. Oh, excuse me. There are some derivatives, but so far we haven't been asked about them. We'll get there. You can see that C has some derivative questions in it. But this first one's not derivative, it's just the functions. But you still have to get g of minus 1 from the table. In other words, the table gives you f of x and also g of x along with f prime of x and g prime of x. But you can get g of minus 1 from that table.
Okay, so that would be -1.
Okay, so what is the answer?
1.
Okay. In other words, I want to make sure you had both negative signs there. You got to include that negative sign even if that's 0. Okay. All right. Let's look at B. So let's rewrite it. F of which is the same as what? F of what?
F of -1.
And from the table?
0.
Huh? Who knew they were this easy, huh?
Yeah, the tables are, I don't know, usually when f of x and g of x come up, it's kind of confusing because it's not like real.
Yeah, no, because you don't know the function. That's the whole point. They're making sure that they don't tell you what f of x and g of x are. Because they want you to apply this particular logic, okay? Now it's going to get a little bit harder. Let's see. This is that f of x prime? No. It's f of x cubed? No, C, what am I looking at here?
F of x cubed times g of x cubed.
Okay. When x is 0. So what is f of 0?
-1.
That's -1 cubed. What is g of 0?
G of 0 is -3.
Now do the math. What do you got?
Positive 27.
Yeah, you got -1 after cubing it times -27 after cubing it. Okay.
Do you still have the picture of the derivative sheet that I sent you last time?
I do. I don't throw away anything. I'm puzzled though here. I guess I didn't read the instructions properly. Okay. It says evaluate the first derivative of each of the following combinations. All right, we weren't doing it right. I apologize. I saw this down here and I thought that was a derivative mark. And so I figured that the derivative questions were in these 6. But now that I look at all of them, I see there's no derivatives at all in any of them. And what am I overlooking here? Well, the instructions. So we have to take the derivatives of these and then evaluate them.
Okay.
So this becomes what? The A becomes what?
Well, so since it's a constant times the function, would the derivative just be 3?
Well, it would be 3 times f of x.
Well, 3 times f prime of x.
F prime of x, I'm sorry. Yeah. And we're going to get f prime of x from the table. So it's not really that much harder, minus g prime of x. And just an example, let's say f of x is equal to x squared. F prime of x would be 2x. So if
Right.
f of x was 3x squared, what's f prime of x?
F prime of x would be 6x.
So you can pull that 3 out. Treat the f prime of x times 3 is what the derivative of that is. With me?
Yeah.
Okay. So now let's evaluate that. So it's 3 times f prime of -1 minus g prime of -1. So what is f prime of -1?
Is -2.
It's positive.
No, 2, positive 2.
Okay, so this is 6 minus g prime of -1.
1.
So that's equal to 5. Okay. Now, this one, differentiate the composite function.
Would that be like the last problem that we did like this?
Yes.
So it'd be,
Composite functions, you use the chain rule. In fact, that's
so that'd be,
the way they start out teaching you about the chain rule, is teaching you about composite functions and why you need the chain rule there. So what is it going to be?
f prime of g of x times g prime of x.
Uh-huh. Now substitute the number for everything.
So f prime of
What goes in the parentheses?
So f prime of g of -1 times g prime of -1.
Okay. Let's start from the inside. Let's see, I need another parentheses there, don't I? Yeah. So start from the inside, work way out. G of -1 is
-1.
so it's f prime of -1. And what's g prime of -1?
1.
And now what's f prime of -1?
0.
And make sure you read f prime of -1.
Oh, 2.
Yeah. So that's 2 for number B. Number C. Now, that's a pretty interesting one. How are you going to differentiate that?
Well, I know we have to use the product rule.
Okay, let's use the product rule. So if y equals uv, then y prime equals uv prime plus u prime v.
Okay. So that would be, so y equals f of x cubed times.
Okay, so y prime equals f of x cubed, okay.
Yeah, y prime equals f of x cubed times 3g prime of x squared.
No, it's 3g of x squared times g prime of x. In other words, that's the chain rule.
Okay.
Right?
So,
in other words, if you had, what's a good example of it? But it's classic chain rule. In other words, you have a function that you're going to use the power rule on, but you have to apply the chain rule to multiply it by the derivative of the inside.
okay.
Plus what?
Plus.
And that's just this part here.
Yeah. So then plus g of x cubed times 3f of x squared times f prime of x.
Okay. Now we just got to fill in the number. Let's see, the number is 0. So it's f of 0 cubed times 3 times g of 0 squared times g prime of 0. If I make a mistake, holler. Times 3f of 0 squared times f prime of 0 times g of 0 cubed. Now we should be able to get all of those numbers from that table. Let me erase what I'm covering up here. So f of 0 cubed.
F of 0 is -1, so then it would be -1.
Times 3 times what's g of 0?
G of 0 is -3, so then 9.
Well, I'm just going to plug it in. I don't want to get ahead of myself mentally. That's the way to make mistakes. Everybody's a little different. You might be able to get away with it.
Well, I make a lot of simple mistakes, so I should probably follow what you do.
On a problem like this, where I've got 6 terms that I'm dealing with, I want to do it one step at a time. Especially when we know we're going to get it right, as long as we just be careful, right?
Right.
In other words, once we get this far, the only way we're making a mistake now is if we make a sloppy mistake. So what's g prime of 0?
4
plus 3 times f of 0.
That would be, so 3 times f of 0 is -1, so -1 squared. 3 times -1 squared.
Okay, and then f prime of 0.
F prime -2.
And then g of 0 cubed.
G of 0 cubed is, so that would be -3 cubed.
Yeah. Now, we're not going to make a mistake. I'm going to change this to a positive 9. And change this to a positive 1. And I'm going to change this to a minus 27. So, what do we have now? Let's see. 3 times 4 times 9 is 108 minus 108 plus, what was that? Minus 27 times minus 2 is 54 times 3 is 162. And it's plus. So
yeah.
looks like we got 54 as an answer.
Yeah.
And I'm still not 100, I wouldn't bet my life on that. As meticulously as I did that problem.
Okay.
I don't think you can do it any more meticulously, right?
Right.
If I made a mistake, it's because I ran out of room and I did stuff like that and stuff like that and stuff like that. So
I wrote it all out and did it in my
Yeah,
head.
same
And
answer. Okay.
Yeah, I got the same answer.
Yeah. Okay.
So next session,
Okay.
I haven't scheduled yet, but tomorrow I'll actually have class because it stopped snowing finally. So we're working on parametric equations still, I think. So then I'll send you those problems
Okay.
as soon as I get them.
Yeah, please, because that's the harder. In my calculus book, that comes after arithmetic infinite series.
Okay.
It does. That's probably the toughest part of Calc BC. Well, I'm not going to say the toughest, but the part I tutor the least. Because most people, even when they take a Calc BC class, they don't get much past infinite series. Even though that other stuff is on the test, parametric equations and their derivatives are on the test. But yeah, go ahead and send it to me in advance and I'll take a look at it and see if I can figure it out.
Okay, yeah, and I'll schedule those 3 sessions here in the next day or so for next week.
Sounds good. Yeah, my next week's going to be a little bit, I've got 3 presentations to do next week, so you might want to schedule earlier rather than later. By that I mean sooner rather than later. I don't care what time of day you do them, but you're going to find my availability a little less available next week.
Okay.
It's a unique week. Okay?
Okay, thank you.
All right, John. Bye-bye.
Bye.